Hello everyone, today we're going to make one of these. Isn't that lovely and shiny? Nice. Now what this does is replace one of those not so nice and shiny. Boo. Now, actually what these are strainers for the bottom of the machine. Now in my milling machine there should be two of these strainers. When I picked it up one had been lost, so I need to make one. And I thought, well, what I do is make two new ones, but what I do is make them of a better design. Now what they're for is when you're using the coolant on the machine, that coolant runs back to the bottom of the machine, goes through these holes, and this strains out all the swarf, so it leaves a swarf on top and just the oil goes through. Wrong. What actually happens is the very fine particles of swarf that the cutters produce go straight through these holes and they collect in the bottom of the oil tank. Then every now and then you've got to dig them all out and clean the oil tank out, which is a bit grotty. Well, I have made a cover before, but instead of just having plain holes like that, I have two pieces of metal, larger holes, so you've got the flow rate through the cover, but sandwiched in between these two plates is a piece of brass gauze, and that's what this does. So when the coolant comes back to the tank, it sits on top, runs through the holes, and then all the swarf is filtered out by the brass gauze that's on the inside. These work really well, so that's what we're going to make today. It's mainly a lathe job. To drill all these holes we're going to be doing that on the rotary table, which is quite an interesting thing to do. Yeah, lots to do, so we best get on with it. Now this is the material we're going to be using for making our two covers. It's 6mm thick, that's about 1/4 of an inch. Aluminium plate. I have two pieces here and two pieces there. These will make the two covers for the bottom of the mill. Now the top part of the cover, I'm going to be turning an aperture underneath there, and that's where the brass gauze is going to be living. Now that brass gauze will be held in place by another plate that goes on. This will be turned down to the same diameter and that will fit on top. Everything will be held together by a bolt going through the centre. There will be an aluminium knob on the top and then a nut at the bottom. Before it's assembled and before I put the gauze in, I'll then be drilling holes through the top and the bottom plate, and that will give a way for the coolant to run through into the tank underneath. Right, let's get this sorted first. We've got this aperture to cut away on the lathe. Let's just make sure that we are home in the chuck, which we are. We need a little divot in the centre of our plate, and using that small divot and a pair of dividers I'll make a circle 102mm in diameter. We need to cut to 103, so this will be our guide to show we're getting close to our finished size. Now I've placed the large centre in the chuck and we drill all the way through with this. We need an accurate hole in the centre of the plate. I drill through with a 10.8mm drill and then ream the hole to 12mm. I use this tip boring bar to undercut the surface of the job. I cut from our marked line into the centre of the job, as this tool gives a better surface finish cutting in that direction. Let's just check the dimensions again. 103.04, that's not bad. And in depth it needs to be 4mm from this surface to that surface. 4mm. The tops to our two filter covers are now machined on the inside with this aperture. That aperture is to hold the gauze, which is going to be the filter material in these covers. We have also drilled in each of the centres a hole and then reamed that out to 12mm. This is the top part of the cover. This is the bottom part. Now the bottom part I've also drilled and reamed 12mm in their centre. Now the next thing we've got to do is shape the outside diameter of the top so it fits the milling machine, and we have to machine the outside face of these pieces to fit the aperture on the underside of the top. Now to do that we can't hold them in the chuck because we need to turn the outside diameters of all four of these pieces of material. So what we're going to do is make up a mandrel, and that's what this is going to be, and I'll be showing you that next. Now, a mandrel is a piece of material that you can put in your machine and bolt your job to. Now on a lathe, they're normally round, and this is a mandrel. It will fit into this collet, which I've placed in the headstock here, and I can just close that collet. Now that mandrel will stay in there, because what happens next is I'm going to turn this end down to 12 millimeters, which means that journal will then be exactly on line with this machine. Now you remember that our job has a 12 millimeter hole reamed in here. Now that hole will slip over the 12 millimeters we've got on the end of the mandrel. The bolt in the end of the mandrel will clamp the job to the mandrel. Now, because there's not that much meat between the faces of the job and the mandrel, I'm going to be using these washers to spread the load, because one of the problems with using a mandrel like this is if I take too heavy a cut while I'm turning the outside diameter here, it will lock and spin in here, and that's not good. The mandrel is made of steel. I turn the front section, check its diameter with a micrometer, remove the sharp edge and check our job fits onto the new 12 millimeter shaft. I then clamp our disc in position with 2 plain washers and an M8 hex bolt. With the job held firmly to the mandrel, I start to turn down the outside diameter of the disc. Once at the correct diameter, I deburr the edges, then take the disc off the mandrel. I've now made the 2 bottoms. I didn't video the process because it's exactly the same as what it was when I machined the top. There's a hole in the centre that's been drilled and then reamed out to 12 millimeter. I put this onto the mandrel, turned the outside down to the diameter required. Now that diameter is of course the same diameter as what's shown on the bottom of the top here. So the bottom fits into the hole in the bottom of the top like that. Ta-da! Now there's one other piece. It's in my pocket just here, and what we're going to need to have on the top here is a handle, because we need to place it into the milling machine and also pick it up when we want to clean it out. So I need to make this handle. Now I made this handle in a previous video. If you're interested in seeing the process of that, I will put the URL in the description, but I'll also put it at the top of the page so you can... Yeah. Thank you, Mr. Editor. So the URL up here will take you straight to the video, which will show here. You won't be able to click on it, but you will be able to type it in. Whilst I'm down here, if you're enjoying these videos, can you... thank you very much. If you're enjoying these videos, can you please go and press the thumbs up? It won't cost you a penny, and it's really good for the channel. Anyway, let's get on with this lid. I have the 2 covers here on the bench drill table. Now I'm going to be peppering this surface and this surface in holes, and those holes will go through the bottom and also the top, and that will allow the cutting fluid to come through the tops. Now there will be a piece of gauze in between which will strain out the swarf, but the problem I have is this bottom to the top, they don't lock together. So when I bolt them back together, I need all the holes to line up to maximise the flow through the covers. So what I'm going to do is pin them together with a pin which I'm going to fit just there on that cross and just here on that cross. Once the pins are finished, then that will ensure that the bottoms will always go back onto the tops in the right orientation. I centre dot where I want the 3 millimeter diameter pins to fit. Next, drill the 3 millimeter holes very carefully and use cutting oil to stop the drill drilling oversize. Using a centre punch, I mark the mating surfaces of each cover. 3 dots on one pair, 4 dots on the other. I now want to make sure that the holes that have been drilled through the 2 plates line up, and I can push the pin, which is there, into the hole. Now, this is the surface that's marked with the 4 centre dots there. This is the surface that's marked with the 4 centre dots there. So I know those 2 surfaces have got to go together. So I will put them together like this. So the top goes on the base, and now I'm going to move it around until the holes line up there. The 3 millimeter pin I have just here. Now the pin has a lead at one end, and then it's just domed at the other. So the end with the lead on, it's just chamfered on that edge. That I'll put in first. Now this should just fit into both of the holes, which it does there. And now if I lift the top off, like this. The pin wants to come with it, so I just touch the pin with this scriber like that. So I now know that the pin and the holes line up nice and neatly. The next thing I want to do is Loctite this pin into the thick plate. Now I don't want any more than 2 millimeters between this surface here and the top of the pin, because that's the thickness of the plate just here. And if it's more than 2 millimeters long, it will sit proud of this surface. Now the reason I don't want it proud of that surface is because the handle will fit on next, and it won't fit properly if the pin is proud of this surface. Now, when you're using Loctite, it's very important that the surfaces that are going to touch together are clean and free of grease. I use a degreaser, I go over this surface, I go over the surface underneath, I get a little bit of cloth which goes through the hole. Once it's all clean, then I'll go over it once again just to make sure. I'll take the pin and degrease that as well on its ends as well as the shaft, and then once that's all clean, I'll get the Loctite, I'll put a little bit in the hole, a little bit on the pin, push the pin into the hole, make sure that I've got my 2 millimeters by using a rule like this. So as long as it's under the 2 millimeter line and there's enough meat here to for the top to engage on, then that's fine. So I did that, left it overnight, and now it's nice and solid, and that's not going anywhere. Now the Loctite that I use is 242. That's a medium type Loctite. If I ever want to get this pin out, all I need to do is warm this surface and then tap that out. At the moment we've got that 3 millimeter pin, and it's going into a 3 millimeter hole, so it's really quite snug and it holds things together very close. But what I want to do is enlarge that hole a little just to make it easier to go together and come apart. So I'm going to put a 3.1 millimeter drill through the hole. That's going to open up the hole by around about 4 thou, 3.9 thou to be exact. The hole is now at 3.1 millimeter, and that's given us our clearance, and now the top goes on and off really quite easily. Our tank covers are now ready to receive their holes, which will be drilled through here, through both of the plates, the top and the bottom. Now to drill the holes and to get them looking nice and neat, they're going to be drilled on the rotary table here. But before we can do that, I need to line up the centre of rotation of the rotary table with the centre of the head just here. I've lined up the rotary table so it's near enough in the correct position under the head of the milling machine. Now with these old machines you always have to worry about the backlash in the threads. Now to eliminate the backlash, what we need to do is put the thread in a known position. So what I'm going to do is on the x-axis, which is this one here, I'm going to turn the handle anti-clockwise, move the table, you see. Now I'm coming back clockwise, and I will keep coming until the 0 on the scale wheel here lines up with the 0 mark on the scale just there. So I know that the backlash has been taken up as long as I move the handle in a clockwise direction. Now we have to worry about the y-axis as well, and on this particular machine the whole head moves backwards and forwards. As you can see here, that's going forwards and now it's coming back. So I'm going to turn this clockwise until the 0 on the scale meets the 0 on the top, line those two up like that. And now I know that there'll be no problem with backlash as long as I move the handles in a clockwise direction. There are several ways we can line up the centre of rotation of the rotary table to the centre of rotation of the head. Now all we're going to be doing is drilling holes, so we don't need to be extremely accurate. So we're not going to use a DTI gauge here. What we're going to do is use this hole in the centre. Now in the centre of this rotary table we have a number 2 Morse taper, and just there, a female Morse taper number 2, but it's very accurately machined and it's bang on the centre of the table. Now in the top of the machine, in the head, we have a number 4 Morse taper, and what I have here is a number 4 Morse taper centre. So I'm going to lift this up, put that in. Now we've got the centre in. So all I need to do is now lift the table, make sure that these two are going to align, and then as it gets close and they start to touch, the clamps, which are loose, That will allow the table to move, but I'll be moving it slightly anyway just to get rid of any stiction. Bring this up until it touches, and then once it's touched, I can then just wriggle this a little bit more to make sure that it's bang on and it's not being loaded in any way. And at that point, I will do up the two clamps. And now that will ensure that the rotary table centre is in line with the centre of the head. So now we're all set up. A piece of MDF is placed on the table first. The job is next and centred on the table using the centre in the head of the mill. Fit the clamps in the T-slots each side of the job and tighten them down. The job is in the centre of the table and secure. Now we need to drill circles of holes around here. Now there's going to be 3 circles. The first circle is going to be made up out of 6mm diameter holes, and that's why we've got a 6mm drill in here, because that's the first row of holes we're going to do. Now we're not going to be moving the head in the Y axis, so I've put the lock on there, but we do have to move it in the X plane in this direction here, and we need to move the drill out 25mm. Now we can't move in that direction on the head, we have to move the table over. So we've got to move the table over 25mm. However, this is an imperial machine, so I haven't got millimetres on the scales. So I need to move the bed in this direction 0.984 of an inch. So that's 984 thou in this direction. Now to drill our first hole, we've got to move the bed in X in that direction 984 thou. Now this is a control wheel for X, and all the backlash has been taken out of it as long as we move it in a clockwise direction. Now one revolution of this handle is 125 thou. Now we've got to move the bed 984. So if we divide 984 by the 125, we end up with 7 and a bit. So if we move this 7 complete revolutions, that gives us 875 thou of movement, which means we still have 109 to go. So 7 complete revolutions. 1, 2, 3, 4, 5, 6. We're coming round to 7 now. That's 7 just there, and now we have to add 109 thou. So we go 10, 20, 30, 40, 50, 60, 70, 80, 90, 109 thou is just there. So we've moved the table 984 thou in that direction, and we don't have to worry about any backlash. We're now ready to drill our first hole. Now on this machine we can drill a hole like this in 2 ways. The first is by bringing a job up into the drill by turning the Z handle, which is down here, and that will lift the whole table, the rotary table and the job into the drill, and the drill will then drill the hole. The other way is by bringing the drill down to the job, and we do that by using the quill which is present in the head. To operate the quill, we've got to turn this 3/8 square shaft. Now when this machine came, it didn't have a handle. Since then I've actually designed and built a handle which works really nicely. Now this is that handle, and you can see that it just slides on to this 3/8 shaft just like that. There's a small handle here you twiddle. This handle is the lock. Tighten that with your fingers, and now this handle is solid on that shaft. When it comes time to take this handle off, all we need to do is undo the lock like this, give it a squeeze, and now this handle will come off the shaft. It's now time to drill our first hole. The operating wheel of the rotary table I've turned in a clockwise direction and brought the 0 round to the mark. So I know that all the backlash has been taken up as long as I turn that wheel clockwise. The wheel, the rotary table itself has got a lock on at the back. It's a hex bolt that's in here, and I've got an Allen key pushed into that bolt, bring it down, and that locks the rotary table. So with the rotary table locked, we're on 0. We can now drill our first hole. Okay, let's familiarise ourselves with this rotary table. The rotary table, just here, all around its periphery here, all around the outside, is divided into degrees. We are seeing the 0 there, and it goes all the way around to 360 when it comes back. This pointer is adjustable, and I've adjusted it such so it's pointing at the 0 degree line just there. The shaft here and this wheel is the operating wheel of the rotary table. If I turn this clockwise, which I have done already when we were setting up, if you remember, so if I carry on turning it clockwise, I will not get into any problems with backlash. If I turn this wheel clockwise, the table will rotate clockwise looking from the top. You'll see that there's a whole load of lines around the outside. Those lines are actually minutes of arc. So 1 minute is 1/60th of a degree. Therefore, if I turn this wheel, now I've taken the lock off the rotary table, so I can now turn this. I'm going to turn it clockwise, and I'm going to turn it until it goes to the 60, which is there. Now that's 60 minutes of arc, and 60 minutes is 1 degree. So if we now look down at our pointer here, it points to the 1 degree mark. If now move this to 120, which is just there, you now see that we're at the 2 degree mark. So it's as simple as that. One whole turn, which we're coming up to now, that is now 180 minutes of arc, and 180 is 3 degrees, and now we can see on this subscale here that we are at 3 degrees. Now the holes that we're drilling on our job are 18 degrees apart, so we have to turn this wheel 6 times between holes. Now we've turned it once already and we've done our 3 degrees. If we now turn it another 5 times, 1, 2, 3, 4 and 5 is just there. So we got that set there. We put the lock on, look at our subscale, and it's 18 degrees, and 18 degrees is the gap between the holes, so we're now ready to drill our second hole. Our first row of holes are now all drilled. We've got to reposition the table, change the drill, and then we can start drilling our second row. I've now placed the 7mm drill in the ER20 collet. When we drilled this first row of holes, the distance we came out from the centre of the plate to here was 984 thou, which was 25mm. The next row of holes, they need to be on a radius from the centre here of 1 inch, 299 thou, which relates to 33mm. So I've now moved that drill out to that position. I've also turned the table 9 degrees, which means this new hole will drill between 2 of the holes which have already been drilled, because if you remember they were 18 degrees separated. So the new one will come down between those 2 holes. The next hole will be 18mm on, which will be between the next 2 holes, and then on we go all the way round until we get a second row of holes. Our second row of holes are now all finished. We've got to change the drill from a 7 to an 8mm drill, reposition the table, and then we can start on our third and our last row of holes. I've now fitted the 8mm drill into the ER20 collet. Now the holes in the second row, they were on a radius from the centre of the plate outwards of 1 inch, 299 thou. The next row is going to be at 1 inch, 614 thou, which is 41mm. Now I've already moved that drill out. In fact, I haven't moved the drill at all. I've moved the table across, so the drill is now in the correct radius to drill this last row of holes. But I've also moved the table around 9 degrees, so it's now in line with the original holes. So the next hole I drill and all the other holes are going to be between the holes which I did in the second row. All 60 holes have now been drilled. My next job is to take the plate off of the rotary table and then deburr all the holes. I've got this side to do, the underside to do, and also I'll take the plates apart and do the two faces that come together. Here we are on the bench drill. I've brought over the top and also the base that we use for drilling the cover on. That's going to go up that way. I'm going to deburr the base first. Now you remember the base has got that pin just there, so I'm going to put that pin in that hole so I know that this is now flat on the piece of wood. I've got the stop on the drill set, so when we bring it down it stops just at the right place where we can come down and just chamfer the top of the hole. The first cover is almost finished. If I take the top off the bottom, the next thing we've got to do is cut a piece of gauze. Here's a sheet of gauze. This is brass gauze and it needs to be cut in a circle just a little bit smaller than the bottom of the cover. Once we've got the gauze, we can then cut a hole in the centre so the bolt that holds the top to the bottom can pass through, and we also need another small hole so the pin which keeps all the holes aligned can fit through it as well. And the first cover is complete. The second cover, I've still got to drill the holes in that and fit the gauze, but that's to do later. I'm trying to finish this video off, so I'm going to push on with this one first. Anyway, I'll bring you in a bit closer, then you can have a nice close-up look at this. Now, I'm quite pleased the way that it's turned out. There are some scratches on the surface, but that's because I used a piece of scrap metal from the scrap bin. But other than that, it looks, I think, really good. I fitted a wing nut at the bottom, and the reason I did that was it makes it easier to take apart and clean in the future. So that's really good, and you can see that it comes apart really quite easily, and the handle just falls out the top. And in the end I didn't make two holes. Do you remember right at the beginning I said I was going to make a big hole and then a smaller hole? Well, it dawned on me as I got the punches out, if I used a larger punch I could then punch one big hole which encompasses both of the holes. So that's what I did. This hole is actually off centre, so I've got to spin it around so I get the right position just there. And now I make sure that that pin is going over the hole, which it is just there, and I can pick it up, put the handle on, then the washer, which then covers up the pin as well as the bottom of the hole, and now the wing nut. So that means that I can take it apart and clean it anytime that I want. Now let's see what it looks like on the machine. We're now looking at the base of the Alexander mill just here. If we put our covers in, there's the completed cover. That fits in quite nicely. There's the second cover there. I deliberately made the handles quite chunky because being at the bottom of the mill, if anything gets dropped, I didn't want the handles breaking off. So they're going to get dented, but they shouldn't snap. Well, the cover is complete, and I think it looks pretty good sat there in the bottom of the machine. So, could you do something like this? Of course you can. And with that, this video is at an end. Take care, everybody. I'll see you next time.